So the next unit that we're going to be working through is on something called linear functions. All right. So basically, what's going to be happening here is in this unit we're going to be graphing lines on grids. Now, the first lesson that comes to this unit is on a concept called slope. So that's the first lesson here: slope of a line. All right. Okay, so as a kind of an example or introduction to the concept of slope, the most, I guess, applicable example in real life would probably have to do with roofs. All right, so I'm just going to use this as kind of like a visual, just as an introduction to the concept of slope. All right, so some roofs are steeper than others. All right, that's pretty obvious. Right? If you look around the buildings out there, and steeper roofs are more expensive to shingle. All right, so to put shingles on steeper roofs, more expensive. I'd imagine that's because of the kind of the danger factor, right? So the steeper the roof, the easier it is to fall off it. Yes. Anyways, so that's why they charge more to shingle those ones. All right, so what I got here are three different pictures of roofs. All right, and the steepness of a roof is measured by calculating its slope. All right, so that's what slopes is a measure of steepness. All right, so I'm just going to box that in there. So in general terms, measure of steepness. All right, so what that means is that if you have a line segment that has a bigger slope, it's going to be more steep. So I'll write that down. All right, so bigger slope is equal to more steep. All right, now that's not all that's involved with slope, but that's kind of like what we're going to start off with here. All right, so what we're going to do here, and what I'm going to show you is how to calculate the slope of each one of these roofs. All right. Now, the slope itself is a ratio. Slope is what we call a ratio. And the ratio it's so basically how the rise compares to what they call the run. So you can see in each one of these diagrams here, we have an arrow indicating the rise. So that's how far that line segment goes up. The run is how far it goes across, right? So it creates these kind of like right triangles. And anyway, so if I take this measurement here, the rise, divide it by the run, it will give me a number. So the steeper the line segment, the greater the slope. Right? And I'm going to just show you using these three. All right. So again, this is roof A, roof B, roof C. So as a simple ratio, slope is actually equal to rise over the run. So you're going to take the count of the rise and divide it by the count of the run. So that's why you can see these pictures here have been kind of like put on top of a grid. So we use that. So let's just calculate the slope of each one of these lines, right? Or each one of these roofs. All right, so roof A, the slope is going to equal, and I'm going to count these ones here. So first, up top there is the rise. All right, so picture here. All right, so please be patient with me. I'm going to count these down here. So 1, 2, 3, 4, 8, 9, 10, 11, 12, 13. All right, so this rise here is 13 boxes or 13 units. Just write the 13 in there, plug that in for the rise, and going across 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13. Oh, okay, so we got the same measurement. So it's 13 across and 13 up. Okay, so the rise is 13, the run is 13. So 13 divided by 13 is equal to 1. All right, so yes, so the slope of this first roof here, roof A, is 1. Okay, so that one. Let's try roof B here. and the slope is going to equal. All right, so I'm not going to write the rise over run. I'm just going to count it. All right, so 1, 2, 3, 4, 5, 6, 7. Yep. All right, so the rise there is 7 units, and the run here is 1, 2, 3, 12. All right, so the run here is 12. Okay, so yeah, so there will be some instances where the slope is a fraction. All right, so this one here would be 7 over 12. Now we can change this as well into a decimal, but I'm not. I'm just going to leave it as a fraction. And for roof C, the slope is going to equal. Here we go again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so the rise looks like it's 14. And the run itself is 1, 2, 3, 4, 5, 6, 7, 8. All right, so 14 over 8. Now, this fraction here I can actually reduce, so I'm just going to reduce that. So slope is equal to 7 over 4. So yeah, so 2 divides into both of these numbers, so I'm just going to reduce it to 7 over 4. All right, so so you can see here that actually, you know what? Let's just it's a little bit easier to see when we compare them. So calculator 7 over 12 equal to 0.58333. 0.583, we'll just round it. And 7 over 4, this one I can do in my head. This is 1.75. Okay, so if we compare the values here, you can see that the roof A has a slope of 1, roof B has a slope of 0.583, and roof C has a slope of 1.75. Okay, so the biggest number here is 1.75, which corresponds to roof C, and visually you can see that it is the steepest roof. Roof A is slope 1, actually roof B is slope 0.583, and you can see here it's the most shallowest or least steepest of these 3 as well, right? And that's the lower number. Right? And then 1 here is in the middle. You can see that this roof here is kind of in the middle of these 2 in terms of steepness. All right, so that's what slope is. It's basically a ratio. This here you'll keep saying in your head probably. Slope equals rise over run. Slope equals rise over run. All right, so just remember it's the measurement going up divided by the measurement going across when you create a right triangle. All right, cool. So in terms of, let me just scroll down here, going into kind of more of a math related slope concept. We're going to use these, we're going to basically get used to using coordinate grids, right? So, and plotting points. Hopefully you guys remember how to do that. And we should be able to calculate slopes given the graph and line segment drawn on the grid there. All right. So I'm just going to go through these ones here. Determine the slope of line segment. All right. So so this slope here, calculate that line segment. Again, we can count. So slope is equal to rise over run. So the number of units. So I'm just going to draw in here. The rise. So that would be 1, 2, 3, 4, 5, 6. So this is 6, and then going across here, it's going to be 1, 2, 6, 7, 8, 9, 10. Okay, so the slope of this line segment is 6 over 10, which is equal to, if I reduce it, 3 over 5. All right, so that's just by counting. Now, what I'm going to do right now is actually introduce a formula, all right, that we can also use to calculate the slope. So rather than counting, because sometimes perhaps this line segment would be like very, very long. You don't really want to count all the squares. All right, so there's a formula that we can use, or we will be using. that will help us if we know the coordinates of the 2 points. All right, so the slope here, I'm just going to write it out first. Right, so it's rise over run. So I'm going to subtract the two y values. Now, first of all, one of them I'm going to label down as y2. Right, so this is just like the second y value minus the first y value over the second x value minus the first x value. Okay, so this is the formula for slope. All right. Now the key thing here is that notice that I have y2 and x2 and y2 lined up, right, as well y1 and x1 lined up. So that's kind of the key point here. So if I was to use this formula for this question or this example, I know that point A here, the coordinates of point A, okay, so hopefully you guys remember that, is the x value is -6. This point here. So x value is -6. And the y value here is at -3. Okay, so this point here is -6, -3. So just remember that the x value comes first and then the y value. So it's -6 this way, down 3. Now the point B here, it's over 4 and up 2, or up 3. All right, so that's +4, +3. Okay, so I'm not going to spend any time really reviewing how to read points off a grid. So hopefully you guys are comfortable with that. Just remember that the x value always comes first. So how far over from this point here, which is actually called the origin, 0, 0. How far over you go, and direction matters, right? So this is negative direction, that's positive direction. That's your x value. And then from here, how far up or how far down you go, that's your y value. Okay. And positive for up, negative for down. Okay, so that's how I got these 2 points for A and B. So if I plug this into this formula, I should get the same answer here, which we will. All right, so slope in this case. Now the other thing is it doesn't actually matter which point you call point 1 and point 2. All right, so and I'm going to show you that in a second here. So let's just say that I call A point 1 and B point 2. Then if I use this formula, my second y value here is at 3. Minus my first y value, which is -3. Now, the signs matter. All right. So notice here that it says negative. So you're taking the second y value minus the first y value. So that's why I have 3 minus -3. So that's why there's 2 negative signs here. One's for the minus in the formula. This is the negative, as in the negative coordinate for this first y value. Okay. And then on the other, underneath here, taking my second x value, which was 4, minus my first x value. Again, I got to include the sign. Okay, so this is how it's going to look when you plug it into the formula. Okay. So this is going to equal, now 3 minus -3 is the same as 3 plus 3. These two negative signs change to a plus, as do these two negative signs, right? These change to a plus. So 3 minus -3, or in other words, 3 plus 3 is 6. And 4 plus 6 is 10. Now, if I reduce this fraction, you can see that it's 3 over 5. All right, which is what we got here when we originally counted. So yeah, so you will need to be able to use the formula. Now, the key thing here again is that the points here line up. So in other words, notice here that I got 3, 4, or 4, 3. That's from point B. And from the first point here, I have -6 and -3, which is point 8. Now, what I mentioned before was it actually doesn't matter which one you assign as point 1 or point 2. So I don't have that much room. Actually, I'm going to do it anyways. All right. So let's say, for instance, instead of calling this point 2 or point 1, I'm going to call it point 2 and this one point 1. I'm just going to show you quickly that you do still get the same slope. All right. So if I switch them around, right, and I call this the second point up top, I'm going to have -3 and then -3 over -6 minus 4. So this time up top, I have -3 minus 3, which is -6, over -6 minus 4, which is -10. Now this one reduces, right? The two negative signs cancel. This is again 3 over 5. Okay, so we still get the same answer. Just in the step before we get the answer, this time we have two negatives that cancel. All right, so either way, whichever point you call point 1, point 2, it doesn't actually matter. Just make sure that in the formula, all right, so just make sure in the formula that these two are from one point and these two are from the other point. Okay, so again, -6, -3 is point A, 4, 3, B. Yeah, so that's the key thing. Just make sure they line up in the formula. All right, so let's try the part B here. So here, point C, if I take the coordinates, is at -3, +4. And point D here is at 2, -6. All right, so I could count, that's fine. However, instead, what I'm going to do here instead is just use the formula. So that's my preferred method. So again, it doesn't matter which one I choose as point 1 or 2, as long as they line up. All right, so I'm just going to go 4 minus -6, and then -3 minus 2. Okay, so this is going to equal 4 minus -6 is the same as 4 plus 6, which is 10. And we have -5. So this slope here is equal to -2. All right, so this here kind of introduces us to another concept, which is positive and negative slope. All right, so notice here, part A here, I got a positive slope, but part B here, I got a negative slope, right, -2. So slope not only measures the steepness, it also tells you the direction that the line segment goes. All right. So in general, if you have a positive slope, the line segment will go up as it goes to the right. Okay. So that's all your lines positive slope. When you get a negative slope, or if a line segment has a negative slope, the direction of that line will always go down as you go to the right. Okay, so this is a key idea. All right. So all lines with a positive slope will go in this direction, as we did in part A. All lines with a negative slope will go down as you go to the right. So this is a very important concept to make note of. Now, the third thing, or the other thing I want to point out here too, is that notice here that it says slope of -2. Right? So what that means is that if I interpret this, so if I interpret this as rise over run, with a slope of -2, this notice that here in the previous step we reduced the fraction, right? It was 10 over 5, but reduced to -2, which essentially is the same as -2 over 1. So what this is saying that for every 2 units you go down, you're going to go over 1 unit, right? So visually, initially we went down 10 and over 5, but you can break this down a little bit, kind of like into smaller pieces. Notice that instead, it's the same as going down 2 over 1, down 2 over 1, down 2 over 1. And when we reduce it, you're still going to construct the exact same line. Okay, so you can get the slope of a line segment. You don't necessarily have to use like the beginning and the end. You can, as long as it falls on a grid, or you can get points that are on the kind of like the crosshairs of a grid, you can break it down further. So I could use point C, and then let's call that point E. I could use that one to calculate the slope. Right? It would be the exact same thing. Right? You should get the same same answer. Okay. Just wanted to show that, right? Because like if I drew a line, but if I drew a line with a consistent slope, you'll end up with the same one. All right. Now, for part C here, instead of giving you the grid, what I decided to do is just make up a question with 2 points, and we're just going to use the formula. All right, and calculate this. All right, so again, slope equals y2 minus y1 over x2 minus x1. All right, so all I'm going to do here is just plug in these points here. Again, the y value is up top. All right, so I'm going to go 1 minus 7 over -3 minus 2. Okay, so now 1 minus 7 is -6, and -3 minus 2 is -5. Now again, the negatives cancel, negative signs cancel. It's equal to 6 over 5. All right, cool. Now, if I do a quick sketch, I just want to double check, make sure I do, when this is true, that we actually draw a line with a positive slope. So we know this line here, according to this calculation, our line should go in this direction. I'm just going to check and make sure. All right, so -3, 1 is approximately here, we'll call it -3, 1, and 2, 7. 2, 7 would be perhaps something like this. So if I was to connect these 2 points, you can see that, yes, we do draw a line with a positive slope. Cool. All right. Now, another concept that I need to introduce you guys is the idea of zero slope and undefined slope. All right, so these are points D and E. So whenever you have a line that's flat, it is known to have what they call zero slope. All right, so for this question here, I'm just going to use it visually. I'm going to use a formula and show you why we actually get 0 if we were to plug these 2 points in. All right? So this point here, we can call -3, -1. All right? So -3, -1. This one over here is +3, -1. All right, so let's just call that A and B. All right, so if I plug these points into the formula, I'm going to have -1 minus -1. And then the x's here, I got -3 minus 3. Okay, so if I work this out, -1 minus -1 is equal to 0. Now, the reason for that, again, is 2 negatives create a positive. -1 plus 1 is 0. Okay, so basically cancel each other out. On the bottom here, I'm going to have -6. All right, and 0 divided by -6 is equal to 0. Okay, so whenever you have a flat line, this is going to equal 0 slope. Always, okay? Because basically the reason for that is because your y values here are always going to be the same in order to draw a flat line, right? So, but if I subtract 2 numbers that are exactly the same, you're going to get 0. So yeah, 0 up top, 0 divided by any number, that's the same as division sign. 0 divided by any number is equal to 0. Okay, so a flat line is 0 slope. Now the one that perhaps is a little bit more trickier is, well, what if I have a line that goes straight up and down? So again, I'm just going to do the same thing here. So I'll call this point A, and that is, oh, they decided to put it in halfway. Okay, that's creative. Anyways, -1.5 is my x, -1.5, and then this is 3. Point B here, and it's -1.5, and this time it's at -3. Okay, so if I use the slope formula for this line segment, y2 minus y1 over x2 minus x1, basically my y values is 3 and -3. So I'm going to go 3 minus -3. And then on the bottom, I got -1.5 minus -1.5. All right, so this time you'll notice here that my x values are the same. So if I work this out, -3 minus -3 is +6. -1.5 minus -1.5. Again, these the same as adding. Those would basically cancel each other out. This time we got 0. Okay, this is where there's a common misbelief, I guess, among some students. Some students think that this is equal to 0, but it's actually not. This is actually what we call undefined, which you'll see in the textbook and stuff. But even more kind of specifically, this is actually infinity. Right? And infinity is undefined. So that's why if you have a line that goes straight up and down, it basically has infinite slope, right? Because it's like a straight drop down. You know what? This may be a little bit above and beyond, but I'm going to actually show you why. When you divide by 0, this is a key concept. And this will show up actually in, for those of you that go on to pre-calc 12, I believe, or maybe even pre-calc 11. Show up there. Anyways, divide by 0. When we divide by 0, this is equal to infinity. And I'm going to show you kind of perhaps to convince you or the reason why that is true. All right, so let's just say I take a number here. I don't know, number 5. All right, the number 5, and I divide it by 0.1. Okay, so this is less than 1, but 5 divided by 0.1 is equal to 50. Well, what about 5 divided by 0.001? Right, so I threw a couple more zeros in there. So that's 5,000. So notice that the answer here is getting big, right? Well, what if I go 5 divided by point? And now I'm going to kind of really exaggerate it. I'm going to hit a bunch of zeros here. 1. All right, so this is a really small number, right? It's really close to 0. Not quite 0, though. But if I hit equals here, the number gets really, really big. So guess what happens when, I'm going to kind of take this to the next level here. And hit 0 until it, oh, I can keep, look at this. I can keep hitting 0, 0. Oh, that's fine. One of those spaces. Let's throw a 1 there. All right, so I'm dividing by a really, really, really small number, right? This number is really close to 0. When I hit equals, all right, this just means it's a 5 with 32 zeros behind it. So you can imagine this is a really, really big number. All right, so theoretically, right, if I actually divide by 0, I'm going to get a really, really, really big number, which doesn't exist. It's infinity. So that's why when you divide by 0, the answer is actually infinity. All right, so this thing here basically has undefined, infinite slope. All right, cool. All right. So the next example here, we're just kind of going to go the other way here, where we're given this slope and we want to draw a line segment. Okay, so in the previous example here, we were given the lines and we're calculating slope. So we're just going to go the other way here and just use that concept of rise over run. Okay, so use the color group. All right, so draw a line segment with one endpoint at the origin. All right, so origin, for those of you that don't know, that is the point 0, 0. Okay. And a slope of, okay, so in this first one here, I want 1 point here, and then 0, 0, and then I want to find another line or find another point that would be on this line segment with a slope of 2 over 5. All right, so if the slope is equal to 2 over 5, again, remember this is equal to rise over run. Okay, so to construct this line, I want to go up 2, and then to the, if I go up 2, and notice again, this is positive. Call that positive slope. Lines go in this direction. Okay, so from here, if I go up 2, I need to go, I'm not going to go left, right? That would create a negative slope. I'm going to go right 5. Up 2, right 5. Okay, so that'll take me to another point on the line. 1, 2, 5. Okay. So the point 2, 5 will actually be on this line segment that we want to draw. Now, what you'll notice here is that from here, if I go up 2 over 5, what you'll notice here is that this third point that I drew lines up with the other 2 points, right? So if I continually do up 2 over 5, up 2 over 5, up 2 over 5, I'm going to create a line because it's consistent. Now, the other thing that I want to point out is that from the origin here, I can also go down to left 5 here, down to left 5. Okay, so what you'll see here is that these 5 points, they all line up in a line. So what I did over here was, I guess technically, I went down 2, so -2, and left 5. So -2, -5. Well, mathematically, right, these two negative signs cancel. So -2 over 5 is actually the same as +2 over +5. Okay, so you can do that kind of trick here where you make them both negative, and then you can continue on in the other direction and find points that are actually in that direction that line up in the line. Okay, so and just to complete this, I'm going to attempt to draw a line through these, but the best of jobs. But anyways, that's how that line segment is going to look, and that's how you find the point. All right, now let's do this one here with -1 over 3. Okay, so again, the slope. All right, so the slope in this case is equal to -1 over 3. This negative sign I could put up top, I could put on bottom, but again, this is just rise over line. All right, so this time it's a negative slope. That means that the line is going to go in this direction. So again, my starting point, 1 point is 0, 0. And this time I'm going to go down 1 over 3. That's another point. And I can continue these steps. Down 1 over 3, down 1 over 3. Now, it's actually, but this is also equal to, and this is kind of similar to what we just did before, is that it's the same as 1 over -3. Right? So I can put the negative sign up top or on the bottom. Now, if you were to technically read this, this would be up 1 and then left 3. So up 1, left 3, up 1, left 3, up 1, left 3. All right, and you just notice again that these points do line up, and we've created a line with a negative slope. All right, so if I connect these points, that's how this line is going to look. All right, so negative slope, again, the line goes down as you go to the right. All right, now for the last one here, now we don't have a fraction, right? We just have slope equals -4. However, whenever any like whole number or integer they call them, we can always convert it as a fraction. Right? So technically, this is over 1. So that's a trick behind these ones. If you're asked to draw a line with a slope of like a whole number, just write it as over 1. Okay? So again, we know that the line goes in the negative direction, and this time, right, we can go down 4, and then to the right 1. All right, so using, again, 0, 0, the origin as the starting point, I'm going to go down 4 for 1, down 4 for 1. And just like the previous example, you can actually write this as 4 over -1, where you could put the negative sign at the other, on the bottom, so the top. So this is also, if you interpret that, that means up 4, left 1. So from 0, 0 here, if I go up 4, left 1, up 4, left 1, that next one's going to be off the grid, but up there. Again, you'll see that these points line up. So let's just draw those in. Yeah. Okay, so that's how you draw that one. All right, cool, guys. So that is the lesson, the first lesson on the concept of slope of a line.